Hello friends, welcome back to my YouTube channel. I will continue my discussion on adsorption. This is part number 8, and under the title of adsorption isotherm, I will be discussing the Freundlich adsorption isotherm in this video lecture. In my previous videos, I have discussed other adsorption isotherms. I am giving link to the entire playlist of my videos on adsorption. You please watch them if you have not yet seen those videos. So today we will be talking about the Freundlich adsorption isotherm. So let us begin the discussion. So representation of the equilibrium, I have discussed it many times in my earlier videos, but in order to have a quick recap of the basic concept, I am discussing once again representation of the equilibrium. So at equilibrium, three parameters that are involved. These three parameters are the concentration of the adsorbate in the fluid phase. We are calling that as Ca, and then you have the concentration of the adsorbate on the surface of the adsorbent. We are going to denote that by Cs, and the temperature. So these are the three parameters that are important when an equilibrium is reached between the fluid phase and the solid phase during adsorption. So, if you have a solid adsorbent which is contacted with a fluid mixture, let us say fluid mixture of A and B. Component A I am showing by yellow color, and there is one more component, let us say component B, which I am showing by a red color. So this is a fluid mixture of A and B, mixture of A and B, and this is the adsorbent. So in this case, A is assumed to be preferentially adsorbing on the surface of the adsorbent, whereas B is not getting adsorbed. B remains in the fluid mixture. So after as the two phases come in contact with each other, molecules of A will be getting adsorbed on the surface of the adsorbent. So in this case, when A is in the fluid mixture, we are saying that its concentration is Ca. And when it goes on the surface of the adsorbent, we are saying that its concentration is Cs. And the third parameter that is involved is temperature. So that is what I have listed over here. At equilibrium, three parameters are important. Three parameters are involved. The concentration of the adsorbate in the fluid phase, that is Ca. The concentration of the adsorbate on the surface of the adsorbent, that is Cs. And then the temperature. So let us continue. I hope you have understood this scenario, and let us move ahead. Let me first erase this. Okay, so the capacity of any adsorbent to adsorb a particular component, it depends on the interaction between these three parameters. The capacity of an adsorbent to adsorb a particular component, it depends on the interaction between the above listed parameters. And if you have to study the equilibrium, what is the easiest way? The easiest way is to keep one parameter constant. So to study the equilibrium, one parameter is kept constant while the other two are varied. So accordingly, you have three different ways to represent equilibrium. You have three different ways to represent the equilibrium. First is, you can plot Ca against Cs by keeping T constant. Then you can plot Ca against T by keeping Cs constant. And the third way is you can plot Cs against T by keeping Ca constant. So since 3 parameters are involved, one can be kept constant and the other two can be varied. And by varying those 2 parameters, you can collect the equilibrium data. And when you plot the equilibrium data, when one parameter is constant while the other two are varying. So there are 3 different ways of plotting the equilibrium data: Ca against Cs, Ca against T, and Cs against T. Ca against Cs by keeping T constant, Ca against T by keeping Cs constant, and Cs against T by keeping Cs constant. So when temperature is kept constant, the resulting curve, the curve that you get when you plot Ca against Cs, that curve is called adsorption isotherm. That curve is called adsorption isotherm. And that is what we are discussing in this video. So one type of adsorption isotherm is Freundlich adsorption isotherm, which I will be discussing in this video. So let us continue. Now there are many adsorption isotherms. I have discussed some of them in my earlier videos. So before that, let us know what is an adsorption isotherm. As I have already told that, so we are going to plot Ca, concentration of the adsorbate in fluid phase, is plotted against Cs, concentration of the adsorbate on the surface of the adsorbent, by keeping T constant. So if you plot Ca on the y-axis and Cs on the x-axis, you will be getting a curve, and this curve, this resulting curve, is called the adsorption isotherm. Then you have to note that this is the commonest way of representing adsorption equilibrium. So out of the 3 ways which I have just told you, this is the commonest way of representing adsorption isotherm, adsorption equilibrium. Then you have to know these facts for adsorption isotherms, and adsorbate will give different adsorption isotherms on different adsorbents. So for example, if A is getting adsorbed on X and another adsorbent, say Y, then for adsorption of A on X, you will be getting a different adsorption isotherm, and for adsorption of A on Y, you will be getting a different adsorption isotherm. So the meaning is an adsorbate will give different adsorption isotherms on different adsorbents. Then the other thing is different adsorbates will give different adsorption isotherms on the same adsorbent. For example, you have adsorbent X and there are 3 adsorbents, say A, B and C. So when A adsorbs on X, we will get an adsorption isotherm which is different from the one that will be obtained when B gets adsorbed on X, which will again be different from the one which will be obtained when C gets adsorbed on X. So in general, we are saying different adsorbates will give different adsorption isotherms on the same adsorbent. I hope this is clear to you. I have discussed it in my earlier videos, but still I am summarizing it so that the concept is clear to you. Now let us list various adsorption isotherms. The simplest adsorption isotherm, how it is obtained, it is the simplest way. The simplest adsorption isotherm, it is used to represent adsorption by very simple mechanisms. The simplest adsorption isotherm, it is applicable when adsorption occurs by simple mechanisms. But adsorption occurring by simple mechanisms, it is very such cases are very few. Very few systems are simple. So if you have to go beyond the simple systems, you will have to use some other way of plotting the adsorption isotherm. So I have listed some commonly used adsorption isotherms. You have the Langmuir adsorption isotherm. I have discussed it. Then you have the Brunner-Taylor adsorption isotherm, or which is called BET adsorption isotherm. I have discussed it. Then you have the Gibbs adsorption isotherm. Again, I have discussed it in my previous video. Then what can you say about these adsorption isotherms? These adsorption isotherms, they are based on some theories that have been proposed in literature. Plus, these adsorption isotherms are applicable to adsorption of gases. And none of them is applicable universally. So you cannot, if Langmuir adsorption isotherm is applicable to one situation, it may not be applicable to the other. That means you cannot use any of the adsorption isotherms universally. Then today I will be talking about the Freundlich adsorption isotherm. What is this? It is, the first thing is, it is not based on any adsorption theory. Like the first three, they are based on some theories. The Freundlich adsorption isotherm, it is not based on any adsorption theory. It is applicable to the adsorption of liquids. The first three, they were applicable to adsorption of gases. The Freundlich adsorption isotherm, it is applicable to liquids. And it is applicable over a small concentration range. It is applicable for dilute solutions. So these facts you have to remember regarding the Freundlich adsorption isotherm. It is not based on any theory. It is applicable to adsorption of liquids. It is applicable over a small concentration range, and it is applicable only for dilute solutions. If you try to apply it to concentrated solutions, you may not get the accurate representation of the equilibrium. So let us move ahead. So I hope this is clear. All three I have discussed. The video lectures are available in the playlist, for which I have given the link in the description section. So let us continue. Okay, now let us understand the Freundlich adsorption isotherm. The Freundlich adsorption isotherm, it is given by an empirical equation. What is an empirical equation? This is a mathematical equation that is derived from the experimental data. It is derived by using experimental data. An empirical equation is a mathematical equation that is derived by using experimental data. So the Freundlich adsorption isotherm, it is given by one such empirical equation. It is applicable to adsorption from liquid solutions. We have already understood this. It is applicable to dilute liquid solutions over small concentration range. You have to know this. First thing is, it is described by an empirical equation. It is applicable to adsorption from liquid solutions. It is applicable to dilute liquid solutions, and it is applicable over small concentration range. Now, to understand, we are going to consider a dilute solution of two components, dilute liquid solution of A and B, from which A is to be adsorbed. So, what we are going to do, a solution of A and B, we are going to take a known volume of solution of A and B we are going to take. And for this solution, let capital V be its volume of the solution. Then Ca0 is concentration of A in the solution. That is initial concentration of A in the solution. It is given as mass of A per unit volume. The concentration is given as mass of A per unit volume. So I am showing, let us represent it schematically. So you have a container and you are taking a solution of A and B in the container, and we know the volume of that solution. Volume is V, and Ca0 is concentration of A in that solution. Concentration is given in mass per unit volume. Now, a known quantity of adsorbent is added to the solution. So we are going to add a suitable adsorbent to this solution whose quantity is known to us, whose mass is known to us. So let a small m represent the mass of the adsorbent. So now adsorbent is added to the solution, and we are going to allow component A from the solution to get adsorbed on the surface of this adsorbent. So I hope you must have understood the example that I am discussing. So when the liquid solution remains in contact with the adsorbent phase, A will be getting adsorbed on the surface of the adsorbent. And in this case, we are going to assume that only A from the solution gets adsorbed on the surface of the adsorbent. So out of A and B, only A is getting adsorbed. This is our assumption. As A continues to get adsorbed, what is going to happen? Its concentration in the solution is going to decrease. So as K from the solution, it gets adsorbed on the surface of the adsorbent, concentration of A in the solution, it is going to decrease. That is, the concentration is going to fall from its initial value. What is the initial value? The initial value is Ca0. So as A continues to get adsorbed, its concentration in the solution decreases, and a stage will be reached when equilibrium is reached. Once equilibrium is reached, equilibrium between the liquid solution and the solid adsorbent phase. Once equilibrium is reached, there will be no net adsorption of A. I have discussed the concept of equilibrium in one of my earlier videos. Again, link to the playlist is available. You can refer that. So once equilibrium is reached, there will be no net adsorption of A. Even though A will be moving from liquid solution to the solid phase, but at the same time it will be moving from solid phase to the liquid phase. As A goes on adsorbing and its concentration increases, the reverse process starts, desorption starts. That is, A starts moving from solid phase to liquid phase. So you have two processes, adsorption and desorption. And at one stage, these two processes will be happening at the same rate. And once that happens, we say that equilibrium is reached. And once equilibrium is reached, there will be no net adsorption of A. Even though A will be moving from liquid to solid phase, from solid phase to liquid phase, there will be no net adsorption of A. This will be a case of this, or this is a case of dynamic equilibrium. So once equilibrium is reached, there will be no net adsorption of A. So at equilibrium, what happens, or what do we have to note at equilibrium? At equilibrium, net adsorption of A stops. I have just explained, and the change in the concentration of A in the solution, it stops. Since there is no net adsorption, no net A is going to the solid phase, its concentration is not going to change after equilibrium is reached. So at equilibrium, the change in the concentration of A in the solution, it stops. So we are going to denote the concentration of A in the solution when equilibrium is reached by CAE. CAE is concentration of A in the solution when an equilibrium is reached between solid and liquid phases. So this is equilibrium concentration, CAE. So as A has adsorbed and equilibrium is reached, what happens? Its concentration in the solution, it reduces from its initial value Ca0 to the value at equilibrium, CAE. So as the adsorption continues till equilibrium is reached, concentration of A in the solution, it decreases from Ca0 to CAE, which is the equilibrium concentration. So I hope you are understanding the concept. If you have any doubt, you please let me know. Okay, so at equilibrium, or we have used these notations for our understanding. I am writing them once again. So Ca0 is initial concentration of A in the solution. It is given as mass per unit volume. Then Ca is CAE is concentration of A in the solution at equilibrium. Again, it is given as mass of A per unit volume. Then small m, we have defined it as mass of the adsorbent used. V is the volume of the solution that we have taken. The volume of the solution, initial volume we have taken. Now from this you can describe or define the apparent adsorption. Apparent adsorption is capital X is equal to Ca naught minus Ca. So you just try to understand, this is the initial concentration of A in the solution. This is the concentration of A in the solution at equilibrium. So the difference between these two, the unit for this difference will be mass per unit volume. And if I multiply this with V, volume of the solution, so volume gets cancelled and you are left with mass of A. You are left with mass of A. So that means the difference between initial concentration and concentration at equilibrium into the volume of the solution is going to give me mass of A that has adsorbed on the surface of the adsorbent. Are you understanding it? So the apparent adsorption is defined in this way. We are going to denote it as X. It is mass of E that has adsorbed. So it will be Ca naught minus Cae into V. Mass per unit volume into volume. So you are left with mass. Mass per unit volume minus mass initial mass per unit volume minus mass per unit volume at equilibrium into volume will give mass of A that has adsorbed on the surface of the adsorbent. So I hope you have understood this. If you have any doubt, you please let me know. So the apparent adsorption is X, capital X is equal to Ca naught minus Cae into V. So this is, let me just erase it. I have just explained this. What is this X? X is nothing but mass of A adsorbed on the surface of the adsorbent. How do you get it? Ca naught minus Cae. You can easily measure the concentration in the liquid solution. The difference into volume of the solution will give you mass of A that has adsorbed on the surface of the adsorbent. Mass of A adsorbed on the surface of the adsorbent. Now I want the apparent adsorption per unit mass of adsorbent. How I will get that? Simply by dividing with the mass of adsorbent, because I had noted down the mass of adsorbent that is being added. So it will be X upon capital X upon M is equal to Ca naught minus Cae upon M into V. So apparent adsorption per unit mass of adsorbent is, you can experimentally determine it. Ca naught can be measured, Cae can be measured, V can be measured, and M can be measured. So in terms of all measured quantities, you will be able to write equation for the apparent adsorption per unit mass of the adsorbent. Very simple thing. If you have any doubt, you please let me know in the comment section. So this is mass of A adsorbed per unit mass of adsorbent. Mass of A adsorbed per unit mass of adsorbent, because we have divided it with mass of adsorbent. So let us move ahead. Now we have got an equation for apparent adsorption per unit mass of adsorbent. It is X upon M is equal to Ca naught minus Cae upon M into V. Now the empirical equation for the Freundlich adsorption isotherm. What is that equation? We are directly using that equation. There is no need of deriving it because it is an empirical equation. It has been obtained by using the experimental data. What is left with us? We have to just verify that equation by our experimental data. That is the main thing. So the empirical equation for the Freundlich adsorption isotherm, it is X by M is equal to K into Cae raised to 1 by N. So X by M, it can be found out experimentally. CAE can be found out experimentally. What you have to get by using equation 1 are these constants K and 1 by K and N. So in this K and N are constants, and how to get them? For that we are going to take logarithm on both the sides of equation 1. So it will be ln of x by m is equal to ln of k into CAE raised to 1 by n. I have simply taken logarithm on both the sides. Let us continue with that. So we have ln of x by m is equal to ln of k into CAE raised to 1 by n. Now on the right hand side, let us use the logarithmic identity. So what is that? Ln of a into b is ln of a plus ln of b. So likewise you have ln of x by m is equal to ln of k plus ln of CAE raised to 1 by n. Then again logarithmic identity. Here we have used ln of n is ln of m plus ln of en. And one more logarithmic identity is ln of m raised to n is n ln of m. So I will use that over here. So that will be ln of x by m is equal to ln of k plus 1 by n ln of CAE. Let me erase it. So accordingly, it is ln of x by m is equal to 1. I have just rearranged it. Ln of x by m is equal to 1 by n into ln of CAE plus ln of k. And now I am calling it as equation 2. So equation 2, it is of this form, y is equal to mx plus c. What is y is equal to mx plus c? It is a straight line. If we plot y versus x, y is equal to mx plus c is a straight line which has a slope of m and intercept of c. So in this case, if you compare y is equal to mx plus c with this equation, y is ln of x by m, x is ln of CAE, slope is 1 by n, and intercept is ln of k. So by knowing slope and intercept, you are going to get the constants. So that is what we will have to do when you have to use the Freundlich adsorption isotherm. The basic job is to find the values of the constants. So you just have to plot ln of x by m on the x-axis and ln of CAE on the x-axis. You are going to get a straight line which has a slope of 1 by n, and intercept of the line on the y-axis, on the positive y-axis, is ln of k. So in this way, if you know the intercept, you can get k. If you know m, you can get n. So this is how you have to use Freundlich adsorption isotherm. We have not derived the equation. We have just understood how we can use the empirical equation for Freundlich adsorption isotherm. How experimental data can be used to find out the constants k and n. So with this, I end my discussion on the Freundlich adsorption isotherm. With this, I complete my discussion on all the adsorption isotherms, all important adsorption isotherms. In my next video, I will be discussing a numerical that will help us in understanding how to use adsorption isotherms, various adsorption isotherms that we have learned. So I will end my discussion for this video. I hope you have understood the concept. If you have any doubts, you please mention them in the comment section. Thanks for watching this video. Do subscribe to my channel. Tell your friends to subscribe to it. Hit the bell icon so that you will be notified as soon as I upload any new video on my YouTube channel. Thanks. Have a nice day and bye bye.